Good afternoon, everyone. Welcome to today's webinar on deep learning at scale, Kubernetes deployment. In today's world, training and deploying deep learning models require massive amount of compute power, efficient resource management, and scalability. Kubernetes or K8s has compute efficiency, has emerged powerful platforms for orchestrating the machine learning workflows at scale. So, what you can expect from this webinar is why Kubernetes is used in machine learning or deep learning workflows, how data flows through this architecture, and how training, inference, monitoring, and scaling happens in production environment. So here, firstly, why we need Kubernetes. So traditional deep learning pipelines are hard to scale manually. It requires GPU, but GPUs are expensive. We must schedule a job efficiently. Models are not done after training. We need further monitoring, retraining, and deployment. So Kubernetes helps with scalability. It do automatic scalings of training inferences. Resource management. It schedules a job on GPU nodes. Security and access control. And also it has monitoring and logging environment. So let's just walk through this architecture diagram. So here we will have first our data sources and storage. So we'll start with first we can have our relational databases, data lake or object storage. These are our raw data repositories. So data will flow into the data ingestion pipeline through them, which extracts and prepare it for machine learning or deep learning workflows. Then it passes through the data pre-processing pipeline, which will handle missing values, which will handle and clean the data. Feature engineering, it will do a transformation. So think about it as in preparing ingredients before cooking. You can't train a deep learning model on a raw data. It needs pre-processing. Okay. So then we will have our Kubernetes cluster, which is nothing but this green box, complete green box. So here we will have our GPU node pool, which is our first component. Okay. Here we are having multiple components. So one by one, we will see all these components. So our first component here is GPU node pool. So it consists of training pods and HPU pods. HPU pods are nothing but a hyperparameter optimization pods. So each pod schedules a job on GPU nodes. So GPU node 1 and GPU node 2. So GPU node 1 is nothing but you are going to train the training pod. You are going to train or run your deep learning models. And HPO pods, which is your node 2, GPU node 2, which will do what? It will trials and take a multiple trials on hyperparameter configurations. And it will do an optimization technique. It will apply all the optimization. See. Okay. All sorts of optimizations. Once the model is trained, the model will go to our inference node pool. Once this model is trained, this model is saved somewhere. The saved model, we can store it in an inference pod. These pods will serve as a prediction in real time to users or a downstream web. They load the model from the model registry and sends the output to the user interface. Then we will have our monitoring and logging. Monitoring and logging are nothing but there are two agents, logging agents and monitoring agents, which will connect the log, matrix, users data, and it helps in identifying the model drift, performance issues, or scaling needs. For example, if too many requests hits an inference pod, Kubernetes can spin up more pods automatically. Okay. Then we will have our security and access management. Within that, we are having RBAC, which is nothing but a role-based access control, which will ensure only the authorized users can run the training or deployed model. Okay. Then we will have a secret manager. The secret manager secures your API keys, credentials, sensitive configurations. All these things will be there in the secret managers. Then after that, we are having the external services here, which are nothing but your user inference and model registry. So, which is a user interface from front end for stakeholders to interact and predict the model, predict the results. Then we will have a model registry, which will store the trained model, manages the versions, and integrates with the inference pods. Okay, so this is the entire workflow of this Kubernetes. First, we will have a data flows within which the data will be there. All the data will be stored here. Once the data is stored from here, we can just push the data from here in the data ingestion pipeline. We will clean the data in the data pre-processing, and then we will have a multiple frames or multiple functionalities are here. Okay, we will have our pre-processed training pods. Okay, this training pods are nothing but this is GPU node 1, and then we will have a GPU node 2. In GPU node 1, the training will be happening. In GPU node 2, hyperparameter optimizations will be happening. Once the model is trained, once the best model is trained, we will save the best model in the model registry. Then for the deployment or inference pod, load the model from the registry itself. Okay. And then predictions are served to users using a UI or an API key. Throughout the process, monitoring agents collects a matrix. Security ensures the safe access is there or not. Okay. So this is how the deep learning is deployed at scale on Kubernetes, which will be efficient, scalable, and secure as well. So let's just have one hands-on this. So here, this is your deep learning model. Okay. So here I have taken this MNIST digits data set. Okay. So, and what we have done means we have load this MNIST data set, which is nothing but a handwritten digits data set. Okay, so we are pulling this data from the data lake or a relational database. After pulling the data from there, we are pushing or we are pre-processing that data using and we are specifically pre-processing that data on for this CNN purpose, because we are using a CNN or convolution neural network to train the model. So likewise, we are going to pre-process the data. So here we will do a scaling, pre-processing, reshape, all these things, normalizing the pixels, all these things we will do here. Right. So we will build our convolution neural network here. So here you can see we have initialized a sequential API, sequential. Okay, model.sequential. So once you will write model.sequential, after that each and every layers will be in a ordered manner or in a sequential manner. One by one, all the layers will be in a ordered format. Model.compile will have the optimizers, loss function and matrix, and model.fit will do what? It will actually going to train your model with 3 epochs. Okay, so we are going to train this epochs and we are going to save this epochs as MNIST CNN model.h5. So we have saved this model here. Okay, we have run this 3 epochs and we have saved this model. Once we have run this training pod or running this GPU node 1 is done. And we have saved this particular hyperparameter optimizations we have used here, which is this optimizer Adam. You can just try it out with Adam, ADA Delta, ADA Post, RMS Prop, any other optimizers you can try and check. Okay. After this, we are just saving our model here. After saving this model, we are using our inference API. This is our inference API. Okay. So here in the inference API, the purpose of this is nothing but to simulate our inference pod, which will going to serve in our predictions in Kubernetes. Okay, so what it will do means it will load your model, which is your .h5 model from the model registry itself. It will start the application. Okay, here we have done a normal application. We can use Fast API, we can use Flask applications or any other deployment server for deploying this particular model. So once we'll run this particular thing, we will get the uh, one link that our URL or URL link whether saying that our model is running here or not. Our server, within our server, our model is running or not. So once we have got this inference pod which is running and which has accepted the 28 by 28 digit images in a JSON format, it will going to predict the results also. Okay, so for predicting the results, what we have done means we have taken this test client.py. Okay, so the same URL which we are going to use here, /predict, we are going to predict and predicting it in a JSON format. Okay, so once we'll run this, let the inference API run at the backend and we have run it in our local CMD. Okay, so we have run this particularly in our command prompt. Okay, so here we have just changed the path of this particular thing, and you can see once you will run this test client.py file here, you will get the API response, and the prediction is saying that this is nothing but the digit is 5 with all these probability scores. Okay, since this data set is nothing but your digits data set, handwritten digits data set, so we have taken this sample client. Let me show you. So here we have just taken this particular samples and we are asking that what do you think, what is it? Which digit is this? So it is giving a response that it is nothing but a digit 5. Okay, so here it will going to generate a 28 by 28 grayscale image. It will send it as in JSON and it will going to predict the results. Okay, so it will receive at the backend, it will receive some response within 0 to 9 digit and it will predict the outcome within that. Okay, so after this, what we can do means we will have our Kubernetes. This is our Kubernetes deployment file. Okay, so this is our Kubernetes, wherein we are going to we will have multiple nodes. All these functionalities will be there. So we will have all kind of training phase, model registry phase. Within the training phase, we will have GPU node pool 1 and training pods. Then in the model registry, we'll have our model, which is nothing but .h5 model. Inference file, we can just see the model is running or not. And then user interference. User interference, we can just see and predict our responses. And then we will have this YML file wherein you can just put all these details of this data set and you can just deploy this model on a server. Okay, so this is all for today, guys. I hope you got this registration for this Kubernetes, how this architecture works and what are the different components in this architecture. Okay, so this is it for today. So if you have any queries or any inquiries regarding admissions, you can call us or you can just mail us. Our salesperson will contact you. Thank you for joining, guys. See you.